Rowan Burns, construction supervisor for Barwon Water. Been on Blackrock Solar project 2 years from concept through to where it was. So we got 1 megawatt, 2,844 panels, roughly 1.46 kilometres in string length of panels themselves. And that's based off seven arrays deep. Yeah. So you can modulate that, and the important part is your string design as to how you want to wire them in a series, but also from a maintenance perspective, it's important that if you need to come out and find if you've got a string failure, how the electricians can then map that you're on string S1 of rack 6 or something, or inverter 6. So. be.on Energy has been the company that's awarded the contract, and then they own a percentage of Next Generation Electrical. So Next Generation Electrical have done the civil works for the project, and then they'll send out different packages of works to DDC is a company that's doing a lot of the pile driving, framing and panel installation as part of Next Generation. They do have that capability as well. Civil works, they're sublet out to an earth moving contractor. This steps up from DC power at 1,000 volts out of the panel strings through to SMA inverters, 415 volt with a power core lockout, or an automatic trip of the main circuit if they require, then steps up to 22,000 volts for nearly a 1 kilometre cable down to our main treatment plant. This was a share farm that was sheep running on it, just as a paddock as buffer land for us. With that concept, we've gone through to keeping ground-mounted panels, about 1 metre off the ground, so we can put sheep underneath them. What it allows is maintenance-free grazing of underneath the panels. Do we put crush rock underneath them, or how do we look at the maintenance of maintaining that around the piling systems themselves? So you have options of putting crush rock down there to limit the amount of weed management that's concerned, and then you would pesticide or herbicide to do that. Then you've got the labour that's involved with undertaking those works. So you need to cost all those factors in when you build a solar system. Yeah. As part of this trial for another project we've got running, where we can't put sheep into the paddock, is actually using robot mowers to set those up, and they'll automatically maintain the grass underneath. Full electric ones that'll come in and they'll go and cut their grass for 2 hours and self-dock, recharge themselves out 24/7, they can cut grass. We've gone Trina solar panels with where they are. They're 2 metres long, 1 metre wide, so we've put them in a portrait mode, so 2 panels high. Frameless, so full glass construction. With those, first generation that we had as part of the project were 355 watts. Going into building our second stage of our solar, we actually procured another 50% of that project, which is probably about 12 months ago, and we got 365 watt panels. And the contractor has just sourced the other 50%, and they're actually 375 watt panels. We have either a 9 or a 10 string process for the panels. So we have SMA inverters, roughly 60 kilowatts each. On the high voltage side, so where we step up, it's a transformer that's a standard electrical transformer that steps it up from that 415 volt through to 22,000 volt. Yeah, so with our design, we've sort of limited balance the proportion of DC to AC power for where it needs to be, and rather than go individual inverter right mounted at the string and then wiring out, we're actually wired out from the string into an inverter mounted in an enclosed cabinet. This project's just running on 12 months coming up now, so we're just going to do that final analysis of what it's put out, and it's certainly going to meet the requirements of our specification. initially Barwon Water, when we went out to spec this, then looked at the market and went with a German Schletter brand of racking, so galvanised piles and then full aluminium framing purlin system with those. So you need to look at your differential metals that are as part of that process, because they'll have 316 stainless bolts with them. We're in a coastal region, so we'd had a fair bit of that, but through that racking company have actually provided a 15-year guarantee on that, right, or a warranty. Yes, so in our stage 2 works, we've actually gone to a different product through SRAC, manufacturers, so SRAC or Schletter, look at the wind loadings that's associated with the panels. So we have outer strings and inner strings, so they will have an outer string closest to the wind environment will have more piles in it than what an inner string will. These have been in 12 months. They've met their solar performance as to what we're expecting out of the panels. We haven't washed them at all to date. So they're a 30-degree inclination fixed panel. We do notice that we're getting some bird life that sits in there in different seasons throughout the year. So we're looking to put some bird spikes just on the top, leading edge of the top panel. Obviously, ground selection where you're going to put your piles in will have a bearing on the supply meeting the obligations of what they need to. So we have 2 sites within our arrays. We've got partial clay where we can ram the piles in, so they go in 1.5 metres into the ground. Unfortunately, we do have some rock in those paddocks, so we've done some initial geotech studies just to try and map where those areas are. Then to pilot, we're primarily augering out the hole to drill that and then ramming the pile in and stave sanding just around that void cavity. 30 seconds per pile to ram those in. We've looked at the safety of working around the inverters themselves, or around the panel, and the framing. So the bottom 2 frames where we have our purlins extend past, we've got rubber caps that we put on them just to make sure you're not scratching as we walk past. Thinking about when you order your panels, how mentioned before that we're in portrait mode, so we have very short tails off our panels. A panel, if it's in landscape mode, needs to join from one panel to the next, so you get very long piggy tails off the back of your panel. If you've got sheep, you've got to coil that up somewhere, so ordering or understanding how you want them to sit means that you can order with short tails, which you don't have any of that issue. Treating your array as it's a power substation, which it is. So 1,000-volt DC power, you can't protect from arcing as you would with AC by putting RCD protectors in them. We've gone the extent of full 1.8 metre barbed chain mesh fencing, concrete plinths around them. So the plinth's sort of 450 wide, 100 mil deep concrete, but we've also inside that put in conduits if we want to put security cameras up on the ends in the future. We've already got that in place. Yeah, so you can put cameras up if we want to monitor it remotely or anything. Power core independently monitor it, they can trip that switch. This is all via remote monitoring via telemetry. So we have string monitoring. So if a panel failed on a string, we'll know that where we can go to fix that, but it probably does help that, and that's 24/7. So if we had someone that thought that they like our panels better than we do, we would know that they've broken that circuit. That stock of panels, we've probably got 20 of them that we'll keep, and we've got 1 inverter for spares out of where they are, just to be able to swap them over as required.